If you remember your quotient property of exponents, right? A to the m over a to the n is a to the m minus n. In other words, if there's 6 11s on top and 4 11s on the bottom, they all cancel, but I'm left with how many 11s and where? 2 on the top, yep. So 11 is 6 minus 4, 11 squared, which is 121, right? I'm just left with 2 on top. Similarly, for this one, I got more w's on top than I do on the bottom. So what's the difference? 21 minus 6 gives us 15, yep. And 64x to the 9th over 60, over 8x cubed, 64 over 8. X to the, good, 9 minus 3, yep. Keep going. Let me have you guys try both of these here. Let me pause that. Check yourself on those. 40 over 8 is 5. 1x left on top, and then 6 on the top, 1 on the bottom for the y, so there's just 5 left over. 20x to the 4th. Any issues on those, you guys? About 80 over 16. What does that give you? Good. And then notice both of your y's cancel, right? Good. All right, well, how about if we have more than just one term in the numerator, but we still have one term in the denominator? In other words, we have a monomial in the bottom, but we have a trinomial in this case on the top. Well, if we just have one term on the bottom, we can use the fact that that's a common denominator and just split it up this way. Let's say that x is a common denominator, right? And then we just simplify it. So we got 8x squared minus 5x plus x over x is 1. Right? That's how we could do that. Let's do it for this one and that one as well. So again, you got one term on the bottom. Go ahead and use that property. All right, why don't you guys try that, the next one, next two right there, both of those, next two. Go ahead, check yourself, make sure you're good on those two. So we've done some polynomial long division, but we've only done the case where we have one term on the bottom, right? That's all we've done. We just divided by one term. And so we split it up just like we've done on these past few examples. So if we don't have just one term on the bottom, we can use polynomial long division always, or another way to divide is called synthetic division that we'll also get into. But let's go ahead and formally introduce polynomial long division. You probably remember the division algorithm with ordinary numbers, ordinary arithmetic. Like, for example, if we take 178 and we divide it by 3. And we do this by hand, right? So we say, well, 178 and we divide it by, 178 is our dividend, 3 is our divisor, right? And then we say, well, 3 can't go into 1, 1's smaller than 3, so let's go to 17. 3 goes into 17. We say, well, 3 goes into 17 how many times? I'm trying to match the 17, right? 5 times, okay, and then I put a 5 right there over that 17. I say 5 times 3 is, yeah, and then what did we do? Yeah, we subtract that. So then we subtract it, right? So then we have 17 minus 15, which gives us 2, and then what do we do? Yeah, bring down the 8. Good. So then we try and match the 28. So we go, okay, 3 into 28. How many times? 9. 9 times 3, good. 27. Don't forget to subtract that. And I'm like, oh, it looks like I have a remainder of 1. And so we would write our answer as 59 plus remainder over the divisor of 3. But we just write that as a mixed number. 59 1/3 is the same thing as 59 plus 1/3, right? That's the division algorithm for arithmetic. We're going to use the same division algorithm, but we're going to do it with polynomials. So this one we have 2x squared plus 3x minus 35. It's being divided by x plus 5. So we're going to go to the side, and we're going to put the 2x squared plus 3x minus 35. We're going to divide that. Our divisor here will be x plus 5. Okay? And so what I'm looking at is I'm looking at that 2x squared, and I'm trying to match that right there. And I'm looking at my x right there. So I say, what times x gives me 2x squared? 2x. Good. Let me get rid of all this junk. (2x), and I put it over the other x. If I line it up with the same degree, it'll just help me out. Okay? So now I multiply it through. So I'm going 2x, taking this 2x, and I'm multiplying it by the x plus the 5. So 2x times x gives me 2x squared. 2x times positive 5 gives me 10x. And then, what are we going to do? We're going to subtract it. And we're going to subtract the whole thing. Well, since we're subtracting the whole binomial, both terms will change. And so I'm just going to put a negative here, and I'm going to change that to a negative there. And so now I got 2x squared minus 2x squared. Well, that's gone. And now I got 3x minus 10x, which gives me negative 7x. And then I'm going to bring down the next term, minus 35. So now my question is, I'm trying to match that negative 7x. You see that negative 7x right there? I'm trying to match it. I have to match it. So now I'm thinking, what times x gives me negative 7x? Negative 7, good. So let's go ahead and plug it in. Negative 7. So negative 7, and I'm multiplying it through that x plus 5. So negative 7 times x is negative 7x. Negative 7 times that positive 5 next to it is negative 35. But don't forget, I got to do what? Subtract the whole binomial. That'll change that sign and that sign. So negative 7x plus 7x, that's gone. Now the question is, do I have a remainder? Negative 35 plus 35? Nope, I got no remainder here. So the answer to this, 2x squared, the answer to that question, right, or the answer to that, if you write it out horizontally, is my quotient, 2x minus 7. That's the answer on that. Okay? Let's do some more. Now notice with this one, your dividend. So you got 3x cubed plus x plus 5. It's being divided by x plus 1, right? So let's put this dividend in. Notice I go from an x cubed, and see how it jumps to an x to a 1 power? So what I'm going to do to make life easier is, if you're missing a term, put in a placeholder. 0x squared is 0, right? So it's the same thing. I'm putting a placeholder in, and then I'm going to go to the x. Then I'm going to go to the constant at the end. It'll make life so much easier when you're doing your polynomial division. So make sure it goes down by a degree each time. If it doesn't, you jump in terms, put in a 0, whatever you're missing. Okay? Now we're dividing by x plus 1. So we're trying to match 3x cubed, right? So the question is, what times x gives me 3x cubed? 3x squared, yeah. And if you're not sure, you can always do it backwards. You can go 3x cubed divided by x, and it'll tell you what you need, right? $3x squared it is. Now let's multiply through. Again, I'm multiplying 3x squared times that x plus 1. So 3x squared times x, 3x cubed. 3x squared times positive 1, positive 3x squared. Don't forget to what? Change the signs, yeah, because we're subtracting that whole binomial. So change both of those signs. 3x cubed minus 3x cubed, gone. 0x squared minus 3x squared, minus 3x squared. Bring down that next term, plus x. Now we got to match negative 3x squared. You see that negative 3x squared in black there? So my question is, what times x gives me negative 3x squared? And you say negative 3x, good. Now so I'm taking negative 3x and I'm multiplying it through. Negative 3x times x, negative 3x squared. Negative 3x times positive 1, negative 3x. Don't forget, change those signs. Negative 3x squared plus 3x squared. By the way, those will always cancel or you did something wrong, right? That first initial term there will always cancel. X plus 3x gives us 4x. Bring down the plus 5. Now we're matching 4x. So I'm like, what times x, right? What times x gives me 4x? And you say 4. Good. Positive 4. So we're multiplying that through. 4 times x, 4x. 4 times 1, positive 4. Don't forget, change those signs. That's gone. 5 minus 4. Hey, it looks like we got a remainder. So our answer to this division is quotient 3x squared minus 3x plus 4 plus remainder over divisor. Plus remainder over divisor. Just like with the numbers. Just like with the numbers. All right, let's keep going here. What's wrong with our dividend on this one? It's out of order, exactly. So make sure you put that in order. Like you should have 3x cubed, then the x squared, then the x, then the 2, right? And if you're skipping a term, put in a placeholder with a 0, right? You're dividing by, the divisor is x squared, but notice there's no x. I'm going to put in a placeholder. For my divisor, x squared, 0x plus 2, right? Because it skipped the bx term, right? And now we're trying to match 3x cubed. So what times x squared gives me 3x cubed? And you say 3x, good. And I put it over the other x. Now let's multiply it through. So I'm multiplying 3x times x squared plus 0x plus 2. Right? 3x times x squared, 3x cubed. 3x times 0x is 0x squared. 3x times 2 is 6x. Don't forget to change all those signs. Change, change, change. Gone. Negative x squared minus 0x squared, negative x squared. X minus 6x, negative 5x. Bring down that minus 2. Now I'm matching negative x squared. So the question is, what times x squared gives me negative x squared? What times x squared gives me negative 1x squared? Negative 1. Yeah, negative 1. negative 1. So let's multiply through. So now I'm multiplying negative 1 through to the divisor. So negative x squared minus 0x minus 2. Don't forget to change all those signs because I'm subtracting that whole thing. Gone. Negative 5x plus 0x, negative 5x. Negative 2 plus 2 is gone. And that's our remainder. So we got 3x minus 1 quotient plus remainder over divisor. Or you can write it same thing, right? Either of those. All right, let's do one more together and then I'll have you guys try a couple of these. So our dividend, we got this negative 3x to the 4th. There's no x cubed term. There's no x squared term. And then we're dividing by x minus 1. And now we're like, what times x gives us negative 3x to the 4th? Yeah, good. 3x cubed. Good. Now let's multiply through. So I'm multiplying this times that, right? So negative 3x cubed times x, negative 3x to the 4th, negative 3x cubed times negative 1, positive 3x cubed. Don't forget to change those signs. So that's gone. 0x cubed minus 3x cubed is a negative 3x cubed. Bring down the 0x squared, because we're going to be multiplying through to two things, right? And now I'm matching the negative 3x cubed. So what times x gives me negative 3x cubed? Negative 3x squared. So let's multiply negative 3x squared times x minus 1. So negative 3x squared times x, negative 3x cubed. Negative 3x squared times positive 1, positive 3x squared. Don't forget to change the signs. And so we got 0x squared minus 3x squared, negative 3x squared. Bring down the minus 2x. Now we're matching negative 3x squared. What times x gives us negative 3x squared? Good, negative 3x. Yep. So negative 3x times x, negative 3x squared. Negative 3x times negative 1 plus 3x. Don't forget, change the signs. Gone. Negative 2x minus 3x. Negative 5. Negative 5x. Bring down the minus 1. Now I'm matching the negative 5x. So what times x gives me negative 5x? Negative 5. Negative 5 times x, negative 5x. Negative 5 times negative 1, positive 5. Change those signs. Change. Negative 1 minus 5, negative 6. There's our remainder. So the answer is the quotient plus remainder over divisor. Either of those forms is fine. Okay?
Am I open that? Either one.
Correct. All right, give you guys a minute. I'm going to have you guys try those two right there. Here's your first one. Go ahead, check that. Should have a remainder of 1 there. Quotient plus remainder over divisor. Second one. A little nastier. It looks like it had a remainder of 1090 on that. Well, that brings us to, you can probably see how tedious this can get, right? A little bit time consuming for some of these problems. There's a shortcut method called synthetic division that is doing this same division algorithm, but it just kind of shortcuts the process for you. But you can only use this synthetic division process when you're dividing by, so you can only do it when you're dividing by something of the form x minus k. K, of course, is a number, okay? That's the only time you can use synthetic division. So synthetic division really is not as powerful as long division. Long division, you can divide anything. Synthetic division, you can only divide by something of that form, x minus k. But this is an example of that. We're dividing by x plus 2. Is this of the form x minus k? And if so, what is your k? Well, think about that as, isn't x minus negative 2 the same thing as x plus 2? So what's our k here? Negative 2. So what I'm going to do is I'm going to put my k in this box right here. Okay? So identify my k first. Now I'm going to put the coefficients of my dividend next. So my dividend has a 1, a negative 7, negative 13, and 15. Now, if I'm missing a term, like for example, if there's no x squared there, if I'm missing one of those, make sure you put a 0 in. Okay? And then what I like to do is I like to put a line right here and I put a line right there. This will be my remainder right there. And so what you do with synthetic division is the first step is you just drop that straight down, that number, 1. So drop it straight down, boom. Now I multiply it by k every time. So 1 times, so I take this times that. 1 times negative 2 gives us negative 2. And then I go negative 7 minus 2, which gives us negative 9. Negative 7 minus 2 gives us negative 9. Now I take the negative 9 times negative 2, gives us 18. I put it right there. Negative 13 plus 18, 5. And then 5 times negative 2 gives us negative 10. Good. And then 15 minus 10 gives us 5. So these right here are the coefficients of our quotient. Coefficients of the quotient. Now, you know how x cubed, all this stuff's being divided by x plus 2, so it's going to be 1 degree less than our dividend that we started with. We started with an x cubed, so this will be 1x squared, 1 degree less than our dividend, minus 9x plus the 5 plus the remainder over what was our divisor? X plus 2. Let me write it up here. X squared minus 9x plus 5 plus remainder over divisor. And that is our synthetic division process. Pretty quick, isn't it? It's kind of nice because it is quick. We do like that. Let's do a few and then I'll have you try this. What's our k here? 3. Good. Positive 3. Make sure you get that k right. What's the coefficients of the dividend? 3. Whoops. Oh, I screwed it up already. What is it? This is not written in order. You gotta be in order. 1, negative 2, 3, negative 4. Follow me? So, yeah, that caught me right there. Again, drop the 1 down. It's the first step. Now we're going to go 1 times 3 gives us 3, and I put it right there. Negative 2 plus 3, 1. 1 times 3. 3 plus 3. 6 times 3. Negative 4 plus 18. Remember, in that little box right there is your remainder, right? That's why I like to separate that right there. These are the coefficients of our quotient. So 1x to the, what was the power we started with? X to the 4th. So it's 1 less than that. So to the third plus 1x squared plus, oh, freak, I screwed this up. Gosh dang it. You guys see what I screwed up? I'm so sorry. That's okay. What I miss? Yeah, there's no, see how it jumps from 3x squared to the constant? I should have put in a 0 before I put in the negative, before I put in the 4. My bad. Sorry about that. Good little lesson. Now let's do it. Try that again. 1x to the third plus 1x squared plus 6x plus 18. Then it's the remainder over our divisor. Of course, you don't need the ones, right? Sorry about that. All right, let's go this one. Do one more and then we'll have you guys try this. Notice it goes from a 5th degree. Well, first of all, what's our k here? 2, yeah. And then it's a 5th degree. Then it jumps to a 3rd degree. So I got to make sure I put in the 0. Don't screw it up like I did last time. Then the x cubed. There's no x squared. Then there's the negative 14x. And then there's no constant either. So put a 0 in because there's no constant. And now let's run through it. So again, it's got to go down by degree, clear until the constant, right? 2 drops straight down. 2 times 2, 0 plus 4, 4 times 2, negative 6 plus 8, 2 times 2, 0 plus 4, 4 times the 2, negative 14 plus 8, negative 6 times 2, 0 minus 12. There's our remainder. Looks like we got another remainder again. So this will be 2x to the what? 4th. Yeah, we started with a 5th, so it'll be 1 degree less than that. 2x to the 4th plus 4x cubed plus 2x squared plus 4x minus 6 plus negative remainder over the original divisor. All right, I got 2 of these U tries, so you guys go ahead and do those 2 right there. Let me pause it. Go ahead, check yourself with both of those. There's that first one. And here's the second one. All right. Well, appreciate you guys watching, taking notes. See you next time.